Welcome to our tutorial on forming fabrics. This tutorial is suitable for the Level 3 Technical Certificate in Paper Making. In other tutorials we've talked about the weaves. In this tutorial, one of the things we'll be talking about is the effect of the weave. As you may remember, the filaments that go in the machine direction are known as the warp filaments, and the filaments that go in the cross direction are known as the weft filaments. So all over the wire we have two parallel warp filaments crossed by two parallel weft filaments, and that leaves a space in between, and that's where the water drains through that space. And this space we call the frame. Here you can see a single layer fabric, and here you can see a double layer fabric, and we're looking at the frame in the topmost layer of the forming fabric. One of the interesting things about this is that the longer the frame in the machine direction, then the more likely it is that fibres will be able to pass straight through that frame and then go out with the white water or the backwater. So there's a relationship there between frame length and retention, and people have done the experiments where they've constructed wires with different frame lengths, put them on machines, measured first pass retention, and one of the things you can see here is that as the frame length increases, then the retention of fibres decreases. If we go back a moment, it's quite understandable, that really, isn't it? But if you've got a fibre coming through here, it's very difficult to get it through this square hole. It's got to go right angles to go through it. But here, where you've got this long pathway, a fibre can come through at quite a shallow angle and very easily pass through there. So it's easy to see that frame length is related to first pass retention. The longer the frame length, the easier it is for fibres to pass through, and therefore the poorer the first pass retention. So in any level 3 exam you should be able to reproduce this graph and explain the situation. Another thing we need to consider on the wire is the wire tension. If I ask the question, is the wire tension the same everywhere? Many students have said, oh yes, of course it must be. But in fact it's not true. Here we have a cross section of the traditional Fordrinia. The dotted line here represents the wire. We have the breast roll, we have the couch roll, we have the drive roll. If you think what's happening, this drive roll is gripping the fabric, it's pulling it along here, and then it's pushing it that way. So if it's pulling it here, that's where you're going to have quite high tension. But if it's pushing it here, then in this area, you're going to have low tension. So the truth is, this is the lowest point in tension, and as you travel around the machine, then the tension gradually increases. And if you were to draw that as a graph, this is exactly what you're going to see. This point here represents the drive roll. When you push it through, there's a rapid fall off in tension. As you go over these rolls and around, the tension slowly builds until you get to this point here, which is where you have maximum tension. Now it's very important to control the tension of your wire. And as the wire gets used more and more, it gets stretched, which is why we have tension rollers on wires. But what about measuring of tension? Measuring of tension is quite important. Where should you measure tension? Well, if you want to know if tension is changing as the wire gets older, you could in theory measure it anywhere, as long as you always measure it in the same place and you see if the tension has changed in that place. So you measure it where it's convenient and where it's safe. But manufacturers will tell you what the maximum tension should be. And if that's the case, then you need to measure the wire tension at this point here. where the wire tension is at its greatest. And it is at its greatest anywhere between these two rolls, between the couch roll and the drive roll. That's where the maximum tension is. And why is tension so important? This is why tension is so important. Again, here we have the warp fibres and the weft fibres just looking at one layer of forming fabric. If your tension's correct, then you'll have this nice big square and stock or water can drain through there very easily. If you apply too much tension to the wire, then you will distort the wire. So you go from having this nice square to this parallelogram. And this parallelogram now has less open area. Because it's got less open area, then it's going to make water more difficult to drain through. So you're going to affect drainage rates, you're going to affect retention, you're going to affect formation, you're going to affect the position of your wet line. So having the right tension is very, very important. Final thing in this tutorial is just a quick mention of fabric guiding. Fabrics never stay in a perfect straight line on their own. We've always got to monitor the position of the fabric, and we've got to nudge it to make a slight adjustment to keep it running exactly where it should do. We determine the position of fabrics by using forks that will sit around the fabric, or spades or paddles that the fabric will press up against, or more and more common these days we're using proximity sensors. Having determined that the fabric is moving, we then need to move our guide roll. And the golden rule about how guide rolls operate is that fabrics move in the direction where it touches the guide roll first. So here we have one guide roll. If we push this guide roll forward, the fabric coming up will touch this end first, and therefore the fabric will go off in that direction. If we bring the guide roll down to here, and the fabric comes on, it will touch this side first, and therefore it will move the fabric off in that direction. So the general principle for guide rolls, the fabric moves towards the side of the guide roll that it touches first. So now a quick summary of this tutorial. The space between the warp and weft fibres is called the frame. Warp fibres are machine direction fibres, weft fibres are cross direction fibres. The longer the frame, the easier it is for fibres to fall through, and therefore the first pass retention will decrease. Wire tension is greatest just before the drive roll, and it's least just after the drive roll. Too high a wire tension will distort the wire, reducing the open area, and so slow down the drainage. And finally, the fabric moves towards the side of the guide roll that it touches first. Thank you for listening to this Paper Classroom video, and I hope you enjoy all my others.